Hello everyone, February 22nd. Alright, it's a little bit late. So let's try to do this fast. However, we have a hard problem. So, and we still haven't read the discussion on this. So I have to read that one too. IPO. Suppose LeetCode will start. Alright, that's what they want, right? That is what they want. Okay, I'll oblige you. I will oblige you. Actually, I don't know. Maybe they're profitable. Who knows? Maybe they are, maybe they are not. In order to sell a good price of shares to venture capital, LeetCode would like to work on some projects. Hold on, when was 502 published? That was a long time ago. They still have an IPO, I think. To increase its capital before the IPO. And they just highlights IPO. I don't know. Since it has limited resources, it can only finish at most K distinct projects before IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K distinct projects. You're given N projects where the ith project has a pure profit. Okay? And a minimum capital is needed to start it. Initially, you have W capital. When you finish the project, you will obtain its pure profit, and the profit will be added to your total capital. Pick a list of at most K distinct projects from given projects to maximize your financial capital, and then return the final maximum capital. Okay, so what you're trying to say is I need to pick K, it can be anyone, in which we are going to have the profit, but your starting W, what if the capital is, oh yeah, it says since your start capital is 0, you can only start the project index as 0, because that one requires 0 capital. After finish, you'll have profit 1 and your capital becomes 1. Then you can start either, then we'll start the one with a higher one. Okay, so K equals 3. We can pick all 3 of them. We start with the first, getting 1 capital, and we start with the second, getting 2 capital. Ooh, hold on. We start with the 1, we're getting 1 capital. Right? And then I'll spend this 1, I get 2 capital. And then for the third one, I'll spend 2, and I get 3 profits. So all we want is the maximum profits, not the final thing, right? Because if you calculate the final thing, right, we get 1 profit, and now we spend 1 profit, and we get 3 profits. So at the end, the net profit is 3, but the total profits is 4. Here is the same, right? Because they require 0, 1, 2. And then I do the first one, and then I get 1 profit, and then I use that 1 profit to do the second one, which I get 2 profits, and I use the 2 profit to do the third one, which gets me 3 profits. So at the end, the net profit is 3, but the total profits, the final maximalized profit, capital, your final capital. Wait, what? The final maximized capital. Let's read again. Finish your obtain profit 1 and your capital becomes 1. With the capital 1, you can either start a project. This you can choose. You need to finish the project index 2, right? To get the maximum capital. To get 2, but you use 1. Hold on. This can be confusing, because if your current capital is not enough, right, you cannot start a project. But if your current capital is so right now you say the capital is 4. But can you start a project with 4? Let's test this hypothesis. Yeah, this is actually very important. It doesn't really matter what we return. So let's say we pick 3, okay? We start with this, and the next one we say 4, but we'll require 4. What you say is the output, the final is, we start with 0, right? And the first, I take 1. The second, I'll take 3. But when I take 3, my current capital is 3, so I shall not take this. So actually, yeah, let's see. What does this one give us? Does it give us 8? It gives us 8. It gives us 8. That is very interesting, which means it considers after 2 projects, the capital is 4 instead of 3. Well, in actual, it should be 3, right? Oh, I think that's what it says. It has a pure profit. And a minimum capital is needed to start it. So it's not, this is a pure profit, which means if your capital currently is 1, right? Your capital is 1, and the minimum capital required to start it, but then a pure profit, okay? Which means you will get that amount of money after deducting the cost, right? You do this and you just earn this amount of money. It doesn't matter. As long as you have the starting capital, you will guarantee to earn that money. All right, that makes sense. That makes sense. Okay. Okay. Oof, how do we do this? We want to maximize our final capital, right? I mean, if we can try binary search again, because this is kind of the binary search week. How would you do binary search? Well, we can set the capital, the final. Well, I mean, we can add all the profits together. That will be the maximized plus W. That will be the maximized, right? And then the minimum will be we don't do anything, so W is the start. So we can find the middle, and we just need to see if it's possible to earn this amount of capital, right? Just to earn this amount of profit, right? I mean, we should additional profit. That doesn't matter, just to earn the profit. So okay, so we have W is the current capital, and then we need to sort the capital, right? Because we need to know which one we can do. So we sort the capital, and we find the one that we can do, and there are multiple, right? So we need to sort capital and profit, put them together, right? So we sort first by capital, increasing, and then if the capital is the same, I want the profits to also be increasing, and then we can use bisect right, right? Bisect right. Then we'll find the maximum we can get given the current capital I have. Then I'll take that, which I'll add that much profit to myself. And then I want, oh, this is greedy, right? Because if you have certain amount of capital, right? If you have certain amount of capital, you always want to earn the maximum. Then why do we do a binary search? Why can we not just go from the start, right? Yeah, because your starting W is this much, right? You definitely have to take the one that gives you the maximum, right? And you take that, then this is current max, and then you go have to find with this amount of capital, what can you do, right? So I think it's straightforward. So here is what I think. Okay, here is what I think. Here is what I think. Do need, say, from bisect import bisect right. Okay, so we're going to sort this thing. Okay, so we say PC capital and profit CP equals sorted for CP in zip capital profits. Okay, and then we're going to do a CP sorted this key equals to lambda tuple, right? So we're going to return tuple 0 because I want to sort by capital low to high. But if they're the same, I want to sort profits. Oh, that's by default. So that should be sufficient. And then we can say W, right? W is what we start with. So we say for this in range K, because at most we can pick K. Okay. And then I say I will do index equals bisect right CP and the current this, right? And this key equals to lambda tuple and then a tuple 0. We'll compare to the first one, right? So now we get an index. And then we need to see if the index is 0, right? That means if index is 0, then we shall return W, right? We should say if index is equal to 0, which means W is smaller than every single thing. Then we just return W, whatever W is right now. We can break and return W here, right? If index is equal to 0. Okay, if index is not equal to 0, that means at least something we can do. So we always try to do index minus 1, right? We try to do index minus 1. So we can say W plus equal to CP index minus 1, 1, because that's the profit. So we add it to it. And let's check if this one works. This one's 6. We have one more from our own. This one is 8 because I added one more, add one more, one more. All right, so now what we need to do is delete all of this, and then we do KW profits capital, find maximum KW profits capital. It works. Let's try. Do you wanna, I don't know, try some edge cases? I don't know, like what type of edge cases you're thinking about. Like 1. Maybe we do this. Okay. Let's try. If it's not right when we handle it. Oof. Ooh. Terrible. Oh, I think we did the same thing twice, maybe. I didn't consider that. 10 jobs. Yep, I did them too many times. Oh, screw me. So the first time it hits and then it increase. Oh, I cannot do it again. I cannot do it again. Oh, so I need to say seen. Okay. If this or index in seen, otherwise seen dot add index. Yep, because you cannot do the same thing over and over again. All right, how about this one? Oh my god. Terrible. Alright, so that's why it's hard. I thought this is all the tricks that we need to deal with. Boy, am I wrong. It's not greedy? Alright, this is bad. This is very bad. Expected is this value. Interesting. How many did we go wrong? Wow, only got half. Oh my god. But why would you not do the maximum? You do 111. And this one, you print it out, it doesn't mean anything. It's just a giant list of things with the costs from small to large. And we start with 12. So I'll start with 314, right? So we can actually see, we don't actually print. Right, we can print for I. Let's print I. Right, the current. I don't need the current W. I do need current W, and I want the index, CP index -1. Right, let's see. I did only 4 rounds, then I call it. Second, third, I add this. So 1710. Oh, shoot. Ah, that's right. That's right. Because if you hit the last one, right? If you repeat, it's in the middle, that means you don't have enough fund. That's it. But if you have a lot of fund, you go all the way to the end, then you can just keep cranking out more, right? So what we need to check is, once we break out, we need to check the index. No, not check the index. Yes, we check the index, right? And we say, if index is equal to 0, then that's it. If not, index is at some place. So if index is smaller, right? If index is smaller, so we say if index is smaller than len CP -1. Yes, it's smaller than that because the index is equal to, right? That means we go to the end. So if it's smaller, then that's it. We return W. If not, right? If not, then we shall do Ooh, I see. I shall do while k, right? And then k minus equal 1. Right? I can add a current k. It's seen before, so we drop out. Right? I drop out. So what this means that my capital is more than the maximum capital. So what I can do is to go through every single one that's remaining inside this list from right to left. Oh, okay, so I can do every single one. So I just go right to left, right? So we say while k again, right? And then we just say no, I want to do this for I. There's no more I. So I say for I in range, right, len cp minus 1, minus 1, minus 1, every single one. We say if I is not in scene, right? If I is not in scene, we say w plus equal to cp I 1, k minus equal 1. Otherwise, I'll skip. And now we say if k is equal to 0, then we'll break. I'll actually do it here. If k is equal to 0, then we'll break. Then we will return w. That's still not right. Why is that still not right? I keep adding if I is not in scene. Hold on, let's print this out. Let's print k and print scene. What do we have? K is this, scene is this, right? And then k minus equal, I can do 107 times. And I will go from right? We start k as this, I do this. K is this. Did I miss? So k is this, I do this, and then k is this, so I jump out. Right? I jump out. And index, we need the index as well. Index is 1000. Right? This is the last one. We have 1000. So 1000, put it in. So these four we just cannot do again. So we go from here. Oh, I cannot. Oh my god. Yes. Ooh. You gotta be kidding me in this one. Okay, so we will do the original, right? Because it's based on the capital we have. Once we get out, we need to resort the whole thing. Sort it again. So we need to resort the whole thing. Damn. So cp.sort. But this time, key equal to lambda tuple 1 minus tuple 1. That doesn't really matter. We could go back into the front, but we'll sort based on the profit. And then we do this. Almost there. Almost there. Almost there. Why is it still not right? Because the indices have changed. Lordy. Lordy. All right. I need to do something. So for profit, right? So instead of seen, I can do something better. So if index is this, right? And then we can say index is 0, definitely it will break, or CP index -1, and because the profit is negative, right? -1 is profit is smaller than 0. Then we do this. We don't have to do this. We'll plus add, and then CP index -1, 1 equal to -1. So this is a sentinel, right? Indicating that this task, this project has been done. Because when we do this, and then we do this, right, it has nothing to do with seen. We can say if index, if CP I1 is larger than 0. And we don't have to do it because we just keep going this way, right? And if this seen is not defined, all right, we don't have to print. That is not what I had expected. All right, that's not what I had expected. I think I'm still short. Why am I still short? See, I have the largest profit, right? Oh, but it's fine because when I sort the first, I already get the largest profit, right? I already get the largest profit. Oh, I see. I see. So your capital is this. What you want to find is the largest profit that's smaller than your capital, right? You're given a capital because we can have something that's smaller. Now, how do we do that? So you have everything, right? Everything that's small. And you want to, okay, on the top it has to be a, so what if we have up until, you sort by the capital, right? You sort by the capital, and after you sort by the capital, you go through everything, so you know the maximum at every station, at every step. So then you say when your capital is at this is the largest, and then you add it, you go here, but then you remove it, right? Then you remove it. You change it and you remove it. I think that's a BIT. That's a binary index tree. We want to find the maximum from a start to this, right? And you also want to update that value, right? You want to update that value, make that into a negative. Because if it's biggest so far, and if it's biggest, then everything needs to change. So what we can have is a BIT, and after we go through the BIT, and we go again, right? We go again, then we can go the same way. Let's see. I'm not pretending I know how to code BIT. Oh, let's see. BIT. I thought you said you're not gonna code it. N, right? N. What's BIT? Self.bit, right? Equals. Screw this. Almost got it, huh? All right. So, size of the range. What's your size of the range for this BIT? Capital, right? So the range is your capital. Because so what we want to know is from this capital to this capital, what is the maximum? And your capital is 10 to the 9th. Jeez. But the profit can be, which means the largest capital that we will ever encounter is going to be 10 to the 9th. It's not going to be bigger than that, right? Yeah, because the capital here is 10 to the 9th. Shoot, can we even do 10 to the 9th? Dude, 10 to the 9th. We're gonna run out of memory. You. Shoot. No, it's not 10 to the 9th. No, it's not 10 to the 9th. It's a total number. It's a total number. It's 10 to the 5th. 10 to the 5th. We can do 10 to the 5th. Yeah, we can do 10 to the 5th. 10 to the 9th is bad, but 10 to the 5th is good. Yeah, 10 to the 5th is good. So we do 10 to the 5th, right? That's the BIT. And update. We'll update a position with a value. It's not a delta. It's just going to be a value. With value, right? With value. Yeah. Time positions. Yeah, that's fine. So there's this, and then while this smaller than shall equal to, I want a maximum of self.biti and value, and this I and minus I. I minus I and minus. This is to get the first. Yeah, I'm not pretending, but this is just to move down to. Is it move down or move front? No, it's move down because you change this. The thing in front of you don't change, but you change the things that beyond you, right? Power of 2, whatever it is. But all right, query the maximum, right? Query the max values in the range to this. Yep. Okay. We don't have to use this. Res equals maximum self dot this and the res, right? And I know where to return res. So that's our BIT. So with this BIT, we don't even have to sort, right? We can just say BIT len profits, right? Then we say for. No, we're still need to sort. Yeah. Then we will sort it. Okay, we sort it. And then we're gonna update the BIT then we say, probably we can say for CP in sorted this. It's not CP. It's but you get the max value, but you do not know where, which one you got the max value at. Oh, Lord. This one doesn't give you the position, right? We can update the position, which is fine. I can get a position here. And at this position, I can update the profit, right? And then I still need binary search because I need to know in this range, which is the maximum, right? But I don't know. I do not know which one's getting taken. Okay? I do not know which one got taken. That's a serious problem. Because this one doesn't tell you. It just tell you up into here, right? Up into here, up into here. It goes just to the front. So you do not know which one gets taken. Okay. I guess it's fine because what I can do is a reverse map from price to price to capital, right? So every time we do, then we get a maximum profit, right? We get a maximum profit. Then we go to the reverse map to see, just take out the smallest. Yeah, we take out the smallest. We take out the smallest and we will put, yes. We take out the smallest index because it's sorted by capital, right? We just say we're gonna take it. Well, we'll take the max profit with the capital smaller than the current capital, right? And if we have multiple projects have the same profit, I will take the one with the smallest capital, which makes perfect sense, right? It makes perfect sense. Okay, so I need, and then I can reverse that, and at the end, once we finish this, right, we get out, and basically I can do the same thing, right? Nah, not really. You can, let's see if you can do, so now I know I can take anything I want. So I just query the last one, right? I get a maximum, and then I'll take that, make that into -1, and then I'll query again. Oh, and then I can update the position. I get its position, I'll update the BIT, right? I'll update the BIT, so that one will never show up. Okay. Here is what we need to do. I need to do a reverse map, okay? I need to do a reverse map. How do we do a reverse map? If I can push it in from small, hold on. From big to small, Okay, big too small. Oh, let me think. What I want is, given a profit, right? Given a profit, I want to know its capital, right? Okay, I can know its capital, right? I know its capital. Because capital is going small to large. Capital is going small to large. Can we go from right to left? If we go from right to left in this, the BIT doesn't care, right? The BIT doesn't care. Okay, so first of all, I still need CP. And the BIT does not care, right? BIT doesn't give a damn. BIT does not care, but our map, so it's be PC map, right? That'll be a default dict of list. So we need a default dict. All right, so what we need to do is for I, we're gonna go for our right to left, and then we can pop the front in range len cp -1 -1, right? So for each one we say cp equals cpi, right? Then we say bit.update, so that I position, right? At I position, I'll update with your profit, and then PC map with the profit, I can dot append I, but that's the largest, right? That's the largest capital. So we'll do that, and after we do that, we'll do this, right? So we'll get the index. If index is 0, then we'll break, right? Or CP this is smaller than 0, we'll break. Yeah, that's fine. It's totally fine. Then we can update this. That is fine. And then we will update this, which is good. And we also need to update, such as we say bit.update. Actually, this is not right. This is not right. Hold on. So we get the index out, right? So this index would tell us, right? This is actually, this index will tell us, we need to go from this to this, right? So index is smaller than 0. This is definitely a no-go. But then what we need to do is find the max. So max profit shall be bit.query, right? Query max range. So max range shall be index -1. This is the max range. So I'm going to start to index -1, right? Because we cannot take index we can't take index. Index could be bigger, the capital. So we get the max profit, okay? And then we can do, this will be plus equal to max profit, okay? So we do the max profit. And after that, we need to find the index that we can do it, which means we can go PC map max profit dot pop, right? That one is, that's the index which has max p and the capital smaller than the current one, and we'll say that one will do bit.update, right? So that position will put a -1 there, so it will be, you know, just gone. Whatever that price is will be gone. Okay, so that's that, right? And then we'll do the next one, right? W we updated, and then we'll do the next one, and we'll do the next one until if the max that pop out, right? So the max p, and we say if max p is smaller than 0, okay, that we also should break. That means we have exhausted all the projects that our capital can do, and then I'll get out. Right? So this is Sentinel. Right? And then eventually index will be big, and I'll just keep doing. And then when we get out, whatever we get out, we just return W, I think. Okay, let's see. How does this one work? Does this one work? If it's 0. Pop from an empty list. Oh, that is troublesome. How would that be possible? If I bit.query, right, the maximum, and I update it, right? I updated the value to -1, right? Update the value to -1. All right, so we need to figure this out. Let's do the first few. Okay, good. We have this one. Okie dokie. So what happens here? What happens here is let's print PC map, right? And let's print max profit. Let's probably also print out index. Okay, just take a look. So the first one says index is 1, okay, because our starting position is 0 and index is 1, okay, so I find a max profit. Max profit is 1. That's fine. So W become 1. Yeah, we can also do W. Max profit W. Right, W become 1. And then I go on for the next one. And then 1 gets popped. Right? And the next time is 2. So we find a maximum. It will be 2. Yes, now we have 3. Now we go 3. Right? Oh, so this is when we already get to the end. There are too many queries. Okay. So we exhaust everything. And I'm keep going. You are keep going. And I would expect, how is max P? So shouldn't max P, hold on, let's put max P up there. I want to see max P here. So max P is 1, we do this. Max P is this, max P is 3. And then we do this. Then we do max P. How is max P still equal to 3? That is bonkers, man. Because I updated. Oh. Wait, what? hold on. This is a BIT issue one. It didn't change anything. So you update this value, right? That's not right. You update I, so self.bit need to first become value. Wait, hold. I updated. What I want is this one to disappear, right? But with this, I never succeeded. So maybe I should do self.bit. Why? I need to assign value to it. Okay. Now it all become this. Now this is what I expect. Right, we have max p, we have a bit, that's good. Max p is a 0. Holy crap. Holy crap. So everyone should start with -1. Everyone start with -1. How is max p still 0? Because the rest is 0. Oh, rest is 0. That will work. Okay, let's comment out the print. Let's try this. Ugh. Why? 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 I don't know. I have no idea. So we start from this, right? And now it's saying if that means we have exhausted everything. Do we dare? Yeah. Let's give it a shot. How many do we do? Oh, that's way too much. That is way too much. Alright, this one also will be way too much. So we can actually take a look at this. Take a look at this. Just get a feeling. So we get, first one we get this. Right, and we got max p, and we got index and current w. So index is 9. Oh. Wait, how many do we have? 1199. We can do that. We can do PC map max p. We have 2. We have this. How come we still get 1199 out? Doesn't make any sense, man. Index is this, right? But I assign it, right? I assign to -1. There's a problem with BIT. I need to update the BIT. I think it's with the update, it's still issues with the update. What shall we do? BIT. Like some value is invalid. How do we get rid of a value that is invalid and have it recalculated? It's the BIT issue. It's the BIT issue. How do you do BIT when the value gets smaller? Let's see. Max binary index tree. Years ago. The update is maximize query instead of changing value. I think it's possible, but yeah, because once the value gets smaller, I don't think that's possible. Right? So the answer is I don't think it's possible, right? That's the general. Then we need segment tree. Oh, I don't think this is a segment tree though. Really? We have to go down segment tree route? No, I don't think so. I think it's just we want to find a maximum in this, right? And we want to find a maximum in this. And we want to find a maximum in this. Maybe a heap? Keep going every time. Just add to the heap, add to the heap, add to the heap, add to the heap, add to the heap. And then you hit something, right? You hit something, which is current is the W is larger or equal to this, okay? Then you do that and you plus this and you keep going and you pop it, right? And then you will take it and you add that. Yeah, I think maybe, hold on. Yeah, this is not working. This is not working, but maybe heap will work. Okay, so a heap. We still need to sort these, okay? We still need to sort these. And say heap equal to this. Okay, so what do we do? What do we do is we will say for CP in. Maybe I can actually do it this way. Right? Then what do? We say if the capital, right, is smaller or equal to the current W. Right? If the capital is smaller or equal to the current capital, then we shall check. Well, we shall first, for every single one, every time we move forward, right, I shall add this, so heap q dot heap push heap minus profit, okay? And then we say while we push this in, right? And then we do this, and then I'll go up. But when do I keep moving forward? That's a good question. When do I keep going forward? Well, I have the W's here, right? And then I will have to go to a point where wait, hold on. I have the current W, right? And I will go until the W is larger than the current. Then I can take the biggest and then give it to it, right? And then to determine whether I can go forward, I need to know whether the next one is bigger than me, right? If the next one is bigger, then I shall move on to the next one. So it's slightly different. So we need to know the next one. So we go here, we do that, right? We add to the profit, and then I see if I can go on to the next one. If I cannot, I'll do it again. I'll do it until I can reach the next one. Then I'll reach the next one. I'll push more in. And then, so basically, this is what I think. Okay. And what we're going to do is I don't know the condition yet, so let's just while true for now. So what do? We say we have I equals 0, right? I equals 0. We say if, this is the first thing, right? That's the first thing. If W is larger or equal to CPI mm, 0, then I say heap q dot heap push heap c minus CPI 1, right? And then I plus equal 1. Come again. If it's larger than this again, I keep push until a point where W is smaller than I. Okay? So W is smaller than this. So I plus 1, so W, so boom, W is smaller. So now W is at a point. So I minus 1 is the point. All right. So if else, then we shall take the largest out of the heap. So we say W will plus equal to heap Q dot heap pop heap. Of course, negative, right? So we pop the largest one profit out, add it to it. Then we go on again. If I am larger than I, then I can add it. But if still smaller than I, then we'll try to find another one, right? We'll try to find another one. And then we can say if heap, right? Then we do this. Else, if we don't have heap anymore, which means then that will be return. That will be break, right? And then we can return W here. Otherwise, I go here. So W is larger than this, and then I will keep adding up. So I has to smaller than len CP. And this is larger than this. Then we go up. But if I was already to the end, so I cannot go, then I just do this and do this, do this. And we can actually say, well, okay, right? Every time we add, k minus equal 1. Okay, let's try this. Oh, this one's right. Oh, wow. So it's a heap. Boys and girls, this is a heap. Got it. It's a heap. It is a heap. Oh, this is a good question. I love it. Because I solved it, right? Okay, so I thought initially that this was a binary such. Boy, was I wrong. Then I thought this might be a binary index tree, but BIT cannot handle a value update where in a tree for max value. but bit cannot handle value update when the new value is not bigger than the previous one. So I was wrong again. Then I realize we can use heap. Right? So the ideal is to sort by capital, right? Then we iterate the sorted capital profit tuple, right? Until the iterate tuple. Each time the capital, right, is larger than W, we push profit to a max heap. Once W is larger or equal to the current capital, it is the entire profits in the heap is available for is available. Thus we choose the max, right? We pop the max. Pop the max profit and add it to W. Now if after added with the max profit, W is still smaller than the next capital, we pop the max heap again and again until W is larger than the next capital, which means we can include the profit of the next capital in the heap as well. Keep going until either we exhaust, right, all K projects, or there is nothing in the heap. The second scenario means, right, the second scenario means with the current W, we have exhausted all projects, all doable projects, and that's the end. Runtime O(n log n). So let's take O(n log n). This take, so O(n log n plus K log n. Not bad. Not bad at all. Greedy approach. Yeah, it's a priority queue. Yeah, that's the same idea. That's pure profit. Yeah. I mean, we did. I mean, we solved it, but it took an effort. Did take an effort. I think in the actual interview, the interviewer will say, well, have you thought about priority queue? And you're like, hold on. Yes, we can do priority queue. Yeah, but the earlier ones was quite bad. Like, why did you choose that? Binary search and choose that first. Who told you that's the largest? Well, it is the largest with that capital, but not necessarily the largest. I think if I realized that, I would have just gone for heap immediately. Yeah, but I did not. All right. That's it, boys. It's a little bit longer than I had expected.